So let's look at our first example using strong induction. So let's define a sequence S0, S1, S2 as follows. So the first term in the sequence, S0, is 0. The second term, S1, is 4. And then we're going to have a recurrence relation. So SK is going to be 6 times the previous one minus 5 times the one before that. So it'll be S sub K minus 2. And that's for every integer K that's at least 2. So we looked at an example of a sequence that involved a recurrence relation. The previous example we looked at only had one initial value. This one has 2, which is also an indicator that you're probably going to need to use strong induction here. So let's start by finding the first 4 terms of the sequence. Well, the first 2 are given for me. S0 and S1 are 0 and 4. So now let's find the other 2. So S2, you're going to use your recurrence relation and you're going to plug in K equals 2 into it. So you get 6 times S1 minus 5 times S0. So if you plug in 6 times 4 minus 5 times 0, you get 24. And then the fourth term, S3. So then you're going to go back to your recurrence relation. You're going to plug in K equals 3 now. So S3 would be 6 times S2 minus 5 times S1. So this will be 6 times 24 minus 5 times 4, or 124. So if I'm looking here, I have this pattern of being 1 away from being a power of 5. And so what we want to do now is we want to prove that Sn is 5 to the n minus 1 for all n greater than or equal to 0. So here, if you look at yours, you had 2 initial conditions here, which means we have to use strong induction. All right, so let's start with strong induction. So the steps are still called the same thing, the basis step. But now instead of 1 value, you're going to have 2 values that you have to show in your basis step. So let's start with S0. S0, if I plug in 0 into this formula, you're going to get 5 to the 0 minus 1. 1 minus 1 are 0. That is true. S0 is 0. We're also going to need to plug in 1 into this formula. S1, 5 to the first minus 1. 5 minus 1 are 4. That is also true. So now my basis step is complete. I can say my formula is true for 0 and 1. And that completes our basis step in this strong induction. So now let's do the inductive step. So we're going to let K be any integer with k needs to be greater than or equal to the largest number from your basis step. My largest number from my basis step was 1. K greater than or equal to 1. And we're going to assume that the formula is true. Si equals 5 to the I minus 1. And this is for each integer I, where I is between 0 and k. So here you're assuming that the formula is true for every value between 0 and k. So let's write down what we have to show. We must show the formula is true for k plus 1. So we must show that sk plus 1 is equal to 5 equals to 5 to the k plus 1 minus 1. All right, so let's look here. What do I know about k? K is at least 1. So since k is at least 1, that means k plus 1 is at least 2. And that means I can use my recurrence relation. And so on k plus 1, so sk plus 1 is 6 times sk minus 5 sk minus 1. So again, what am I doing? I'm going back to my recurrence relation. So go back up here. And I'm plugging in this formula. I'm replace k by k plus 1 in that formula. And so you're going to get, if you replace k in that formula with k plus 1, you get 6 times sk minus 5 sk minus 1. And then you're going to use this formula right here for these two terms here. So you're going to replace, first you're going to replace I by k. So you get 6, 5 to the k minus 1, minus 5. And then you're going to replace I by k minus 1. So this will be 5 times 5 to the k minus 1 minus 1. And now we're going to simplify, and in the end, we want to get this thing right here. So let's distribute the 6. Let's go ahead and distribute the 5. I'm going to go ahead and combine this minus 6 and plus 5. That will be a minus 1. And then I'm going to combine these. Oh, sorry, that should be a k minus 1 here. K minus 1. So I'm going to add the powers. So it'll be minus 5 to the k. And then what I'm going to do is factor out a 5 to the k out of both of these in the front two terms. So 5 to the k will be 6 minus 1, or 5. And again, these have the same base, so I can combine them together and get my formula. I was trying to get 5 to the k plus 1 minus 1. And that's what I was trying to get to. So again, strong induction is very similar to regular induction. The basis step and the inductive step are just a little bit different.